Good evening, everyone. We welcome you all for the day 4 of the 5 days online workshop on SPSS and research. Today's topic is Ankova and Mankova. Now the session was handed over to today's our resource person, Dr. T. Kumaresan, sir.
Very good evening, sir. Thank you.
Thank you, sir.
Very good evening, all my dear friends. Very happy to meet you once again for the 4th day session today. Today, we are going to discuss about somehow different tools. One is Ankova and another is Mankova. Yesterday, we had discussed about two tools, ANOVA and MANOVA. Analysis of variance, univariate and multivariate. ANOVA, one-way ANOVA and two-way ANOVA. MANOVA is multivariate analysis. In the multivariate ANOVA, the number of dependent variables would be 2 or more, irrespective of the number of independent variables. So any number of independent variables, any number of dependent variables. For that, we applied MANOVA. Today, it is somehow different from the previous tools. Ankova. ANOVA means analysis of variance. Ankova means analysis of covariance. That's all. So as usual, Ankova means univariate. Mankova means multivariate. That is the only difference. The same as we discussed yesterday. ANOVA. In the case of ANOVA, only one dependent variable. Number of independent variable, maybe 1, 2, 3, 4, or 5, and so on. If there is only one dependent variable and one independent variable, one-way ANOVA is applied. If there are 2 or more dependent variables and 2 or more independent variables, we applied MANOVA. Two-way ANOVA is applied where there is only one dependent variable and any number of independent variables. The condition is dependent variable must be scale data. Independent variable may be ordinal or nominal. In the case of Ankova, analysis of covariance. What is covariance? We have one more type of variable called covariate variable. Apart from independent variables and dependent variable, now we are introducing one more variable called covariate variable. In the case of ANOVA, dependent variable and independent variable. the independent variables influence the dependent variable. We know the independent variables may be categorical, ordinal, or nominal. If it is ordinal or nominal, we call it as categorical. Here, we are introducing one more variable called covariate variable. Covariate variable is also scale data. Dependent variable, scale data. If both are dependent variable, we can calculate correlation between these two variables. That is covariate variable and dependent variable. In the case of ANOVA, the independent variables are influencing the dependent variable. But in that case, we are not supposed to calculate the coefficient of correlation between independent variables and dependent variables because they are not scale data. If we want to go for correlation, it is a condition that the variables must be scale data. All the variables to be compared. If in the case of simple correlation, we are comparing two variables only, in that case, both of the variables must be given in scale data. In the case of multiple correlation, there may be different number of variables, say 3 variables, 4 variables, 5 variables, and all. In that case, all the 5 variables must be scale data. One ordinal data, one scale data cannot be compared for correlation purposes. For correlation purposes, all the variables must be unique, uniform, same. If one is scale data, others also must be scale data. If all the variables are scale data, we apply Karl-Pearson's correlation coefficient. Karl-Pearson's method was applied and Karl-Pearson's coefficient of correlation was computed. If all the variables are given in ordinal data, then also we can compute the correlation coefficient, but we have to apply Spearman's rank correlation coefficient. So a mixture of scale data and ordinal data cannot be used for correlation purposes. Otherwise, in the case of regression, we can use dependent variable is scale data and independent variables may be ordinal or scale. But while applying correlation, all the variables must be scale data. Then we can apply Karl-Pearson's method. If all the variables are given in ordinal data, we can apply Spearman's rank correlation coefficient. So one variable is scale data, another variable is ordinal data, means you cannot apply correlation. Now, come to ANCOVA. There are two variables given in scale data, and we can find the correlation coefficient. Moreover, even in the case of correlation or ANOVA, we know that the independent variables influence the dependent variable. In the case of correlation, all the variables are interdependent. Now you just combine the two methods, ANOVA and correlation. Sir, how can it be combined this? In the case of ANOVA, independent variables are ordinal variable or ordinal data. Dependent variable is scale data. In the case of correlation, all the variables are scale data. Here, there is a mixture of scale data and ordinal data or nominal. But a new concept is introduced, covariate. Covariate means there is a correlation between this variable and the dependent variable. Even though independent variables influence the dependent variable, the influence of covariate variables on the dependent variable is certainly existing. That is, there will be correlation between covariate variable and dependent variable. The independent variables could influence covariate variable as well as the dependent variable. So there are three types of variables. Unlike in the ANOVA, there we had only two types of variables, independent variables and dependent variables. So here one more variable is added, that is called covariate variable. But both covariate variable and dependent variable must be scale data. Here also, in the case of ANCOVA, only one dependent variable. I told you, no, univariate means only one dependent variable. Univariate ANOVA, only one independent variable. Only one dependent variable. One-way ANOVA, one independent variable. Two-way ANOVA, two or more independent variables. MANOVA, two or more dependent variables, two or more independent variables. So it is higher in order when compared to the ANOVA and MANOVA. So the additional variable is included. That additional variable is the covariate variable. So both the covariate variable and dependent variable must be scale data. Irrespective of number of independent variables. There may be two or more independent variables. Even one independent variable may be there. Similarly, no restriction on number of covariate variables. There may be one, two, or more variables, more covariate variables. But the thing is, they are correlated. Covariate variable and dependent variable are correlated because we can compute the correlation, whether there exists correlation or not. You know pretty well, correlation always exists. Correlation always exists between two variable data, two scale data. If n is equal, so the degree only will be different. If rho value is 0, there is no correlation. Otherwise, the correlation coefficient will be between -1 and +1. If it is less than 0.05, very low degree of correlation. Between 0.25 and 0.5, low degree of correlation. Between 0.5 and 0.75, moderate degree of correlation. Between 0.75 and 0.9, high degree of correlation. Between 0.9 and 0.99, very high degree of correlation. If R value is, or rho value is 1, then we say there is a perfect correlation. So definitely, when two variables are compared, there will be a correlation. Unless otherwise, the correlation coefficient is 0. Only thing is the degree may be different. Very low, low, moderate, high, very high, or perfect. So here, there may be two or more independent variables, two or more, even one independent, one covariate variable may be there, any number, either 1, 2, 3, or more. But in the case of ANCOVA, there must be only one dependent variable. So no restriction or no limitation on the number of independent variables and number of covariate variables. But only one dependent variable. Both are scale data. Scale data means we can go for correlation, irrespective of the degree of correlation. Suppose we are using only one covariate variable and only one dependent variable, there is a simple correlation. If you are using two or more covariate variables and one dependent variable, we can go for multiple correlation. Now, it should be made clear. Suppose two independent variables, two covariate variables, and one dependent variable. First, we go for correlation. Correlation between covariate variable 1 and dependent variable. Second, correlation between covariate variable 2 and dependent variable. Or sometimes correlation between covariate variable 1 and covariate variable 2. This is on the part of correlation. Suppose, since there are two independent variables, we can go for two-way ANOVA. In this case, we can go for three sets of two-way ANOVA. One is, we take the two independent variables as it is, and the first covariate variable as the dependent variable, and we can go for two-way ANOVA. First one. Second one, independent variables as it is. The second covariate variable is considered as dependent variable, and we can go for two-way ANOVA. Third one, two independent variables are taken as it is, and the actual dependent variable is taken as it is. So we can go for the third two-way ANOVA. So why should we go for three ANOVA, three two-way ANOVA, three correlation, four correlation? I want a crisp result, sir. Instead of doing lot of analysis, I want to do a single analysis, sir. If you feel so, then your right choice should be ANCOVA. So there is a correlation between covariate variable and dependent variable. That is why we call it as covariance. Analysis of covariance. Analysis of variance is ANOVA. Analysis of covariance is ANCOVA. So correlation should be prevailing between covariate variable and dependent variable. This is one condition. Both should be scale data. The influence of independent variables may be on covariate variable and on dependent variable. These independent variables are ordinal or nominal. That's all. That's all we need to know about the ANCOVA. So with this, we'll go for the data. Look at here. The problem is ANCOVA. The following are the scores obtained by 30 students of a college in model exam and university exam. Gender, specialization, model exam marks, and university exam marks are given. You are required to examine whether there is any significant variation in the scores obtained by the students in the model exam and university exam with reference to their gender and specialization. Now, you may be asking, sir, what is the difference between this problem and MANOVA problem? See, here also two variables are given in scale data. Two variables are given in scale data. We can compute correlation also here. There are two independent variables. These variables can influence these two dependent variables. Here, these two variables are called dependent variables. But here also, we have two variables given in scale data. Two independent variables are there. Sir, how can I understand or how can I decide whether I should apply MANOVA or ANCO? In the case of MANOVA, these two variables are dependent variables and scale data. See, both the marks in corporate laws and marks in auditing are different. Maybe in the model exam or maybe in the university exam, both must be either in model exam or in university exam. So here, even though these variables are given in scale data, the correlation is not expected irrespective of the degree of correlation. It is not expected or otherwise it is not considered. But in the case of next problem here, model exam and university exam. For what purpose model exam is conducted? Model exam is conducted to help the students prepare for the university exam. Normally, based on the model exam marks, we come to a conclusion that these students will score this much of marks in the university exam. We can just predict, not using regression method. We can just assume, not predict. We can just assume based on the performance in the model exam, we can assume that this particular boy or girl will score this much of marks in university exam. So based on model exam marks, we suggest them or we offer additional coaching to the university, to the students for performing better in the university. So model exam is a criterion to assume the scores to be obtained in the university exam. So model exam is foundation based on which the university exam scores will be there. It is just an assumption, not actual. Actually, whether the model exam supports the students to perform better in the university exam or not is the matter. The matter is we conduct the model exam to support the students, understand their level of performance and what measures to be taken by them to perform better in the university exam. For that purpose, model exam is conducted. So obviously, in the case of university exam marks and model exam marks, there will be a correlation between these. Correlation between model exam marks and university exam marks. It need not necessarily be, that is different. But we expect that this performance will be continued in the university exam also, or it may be improved hereafter. But unlike this, in the case of MANOVA, the two marks are entirely different, even though there is a high degree of correlation between these two. Corporate law exam is not conducted to improve the performance in auditing exam. So these two are entirely different. Even though there is a correlation, very high degree of correlation between these two parts. Here, in this case, why the model exam is conducted? To get the students improve their performance in the university exam. So they identify, they understand how they have performed in model exam, whether it is up to the expected level or not. If it is expected level, how to proceed further. If it is not up to the expected level, how to improve. For that purpose, the model exam is conducted. So in the previous case, that is MANOVA, these two variables are considered as dependent variables only. But here, even though these two are maybe these two may be taken as dependent variables. I told you no. Relationship between independent variables and covariate variables. Relationship between independent variables and dependent. So relationship between independent variables and covariate variable means the covariate variable is considered as dependent variable. But unlike in the case of MANOVA, model exam is helpful to improve the performance of the students in the university exam. So we call it as covariate variable. That's all. See the difference between MANOVA and ANCOVA. So correlation is considered. One-way ANOVA is considered. Two-way ANOVA is considered. MANOVA is considered. All these four tests are combined in a single test called ANCOVA. Understand? Okay. Now come to the independent. There are two independent variables, gender and specialization. What is the condition for applying ANOVA? There must be at least 3 categories of at least one of the independent variables. There are two independent variables, gender and specialization. Gender is divided into 2 categories, male and female. Specialization is divided into 3 categories, finance, marketing, and HR. So the condition, at least one independent variables must have at least 3 categories. Here, even though gender has only 2 categories, since the specialization has 3 categories, it is appropriate to go for ANOVA. Then one-way ANOVA, two-way ANOVA, MANOVA. Now we come to ANCOVA. That's all. So I think you will be clear about this. Now, since it is an advanced tool, let us have some clarification before going for problem, because it should be understood clearly. If suppose anybody having any clarification, now itself you can ask, then we will go for analysis. Dear friends, sir, Sekhar sir, please give unmute option, or you can put it in the chat box. Dear friends,
No doubt, sir. No doubt.
no doubt. Okay, sir. Thank you very much. Thank you. So we'll go to the analysis. Look at here. Look at the variables. You know the same thing. Gender, specialization, marks in, model exam and university exam. We go to analyze. General linear model as it is. Univariate, the same. What we did yesterday for two-way ANOVA. Univariate, right? What is the dependent variable? university exam marks. University exam marks is the dependent variable. See here also, the box size shows that only one dependent variable can be accommodated. Look at the fixed factors. It is meant for independent variables. So the box size implies that any number of independent variables can be included. Look at the covariate box. Any number of covariates can be added. So first we have taken the dependent variable. Then what are the independent variables? Gender and specialization. Okay. Now what is the covariate variable? Model exam scores. Actually, at the initial level, it is okay. Now you can click OK. Look at the results. First description. There are 15 male students and 15 female students. 12 finance students, 11 marketing students, and 7 HR students. Look at here. Model exam is the covariate, so it comes first. But look at the p-value. 0.937. 0.937. .937 means it is greater than 0.05. If it is greater than 0.05, we say that there is no significant influence of model exam marks on the university marks, university exam marks. There is no significant influence of model exam, that is covariate. I told you the covariate variable may, not must, may influence the dependent variable. But for understanding only, here it is given as not significant in this case. But most probably, this covariate variable would be influencing significantly the dependent variable. Then what are the independent variables? Gender and specialization. No significant influence of gender because p-value is 0.949. It is greater than 0.05. So the influence of gender on university exam is not significant. Then specialization. P-value 0.604. That is also greater than 0.05. So there is no significant relationship between specialization and university exam marks. Then gender and specialization interaction. P-value is 0.168. That is also greater than 0.05. So the impact made by gender specialization interaction on university exam marks is not significant. Look at the R square. 0.133. That means 13.3% of university marks alone has been influenced by these independent variables and the covariate variable. At least the R square value must be greater than 0.5. Then only we can get the results that either the covariate variable influences the dependent variable significantly, or the independent variables influence the dependent variable significantly, or the interaction of independent variables influences the dependent variable significantly. But here R square also less than 0.5. P values are greater than 0.05. So what we expected, model exam marks will support the students to improve their performance in the university exam. But here it is not happened so. Gender has not influenced the university exam. Specialization has not influenced the university exam. Both gender and specialization have not influenced the university exam marks. R square is less than 0.5. At least it must be greater than or equal to 0.5. Then only we can get better results. But here, none of the independent variables, or neither of the independent variables nor the covariate variable has influenced the dependent variable. This is a basic analysis. At the advanced level, we can go for some more options. Yeah. Once again, go to analyze. Go to general linear model. Univariate. Now this window contains the boxes in which we have entered. Some more buttons are on the right hand side. First one, model. We have to specify the model. Full factorial model or customized model. Generally, we are going for full factorial model. So it is given in default. Suppose if we go for custom model, see what are the factors and covariates, we have to define the model here. But since we are going for full factorial model, there is no need for custom. Then come to sum of square. Type 3 only is given in default. There may be type 1, type 2, type 3, and type 4. So there are 4 different types of sum of squares. We are going for type 3 only, most probably. So we have the type 3 model. It is given as it is. Then whether to include the intercept in the model or not. Obviously, we include the intercept in the model. Suppose if you don't want to include the intercept, we can uncheck. We are using the intercept in our model. So that's all. Once again, I repeat, go to the model specification. Full factorial model. It is selected in default. Sum of squares type 3 selected in default. Then include intercept in the model selected in default. So go to continue. Then don't bother about the contrasts. Here, gender of students is considered as contrast. Specialization is considered as contrast. Here only we have to show whether deviation or simple or difference. Different types of contrasts are there, but we are not going for that. So straight away, continue. Here we need not save anything now. You can go for options. Look at here. Whether the means are to be displayed. Yes. Estimated marginal means we need. Suppose at the basic level, I told you, no, they are not considered. Now, a little bit we are moving towards advanced model. So we select. Sometimes many statisticians will go for overall only, but nothing to do with the overall alone. So better we can go for all.
चौकीदानी यही तो आ रहा है 2.7 किलोमीटर से.
Then we select
चौकीदानी रिजॉर्ट
descriptive
रोड
statistics.
नहीं चौकीदानी आ रहा है. मैंने डाला
तो ठीक है फिर चौकीदानी जयपुर.
अब ये कोई और है तो ये
Descriptive
भी
statistics.
4.1 किलोमीटर.
Then continue.
कौन सी है चौकीदानी?
Significant level
यही है जयपुर वाली
already
और
given
क्या.
as
ये बस
0.05.
मैं चौकीदानी डालता हूँ.
So confidence
हाँ.
interval
ये
is
सबसे पास एक और
95%.
आता है 2.7 किलोमीटर.
देखना
So
इस पे फोटो
significant
में क्या
level
आ
is
रहा है.
5%. Then click continue.
ये
That's
थोड़ी है चौकीदानी करना आ रहा है.
Now click OK.
अरे पास ही है वैसे.
Host, please unmute Simran Kaur. Host, please unmute Simran Kaur.
गूगल पे
Simran Kaur, you can mute and talk to others. Thank you. Now look at the results. Earlier, we had only 2 tables. Now we have number of tables. Look at the first one. That is as usual, the same result. Then come to the descriptive statistics. I told you, no, descriptive statistics contain the mean and standard deviation. See here, we are having 2 independent variables, gender and specialization. So in each specialization, for each gender, what is the number and what is the mean and standard deviation? Look at here. As far as the male students are concerned, look at here. There are 15 male students. There are 15 male students. Otherwise, I'll bring everything to the Word document. Look at here. Let me paste it here. This first table says that there are 15 male students and 15 female students. 12 finance students, 11 marketing students, and 7 HR students. But we do not know how many male students have the finance specialization, how many male students have marketing specialization, how many male students are there in the HR specialization, we do not know. Similarly, in the case of female also. But here you look at the table, male, total 15 students. 8 students have chosen finance specialization. 7 male students have chosen marketing. But none of the male students have chosen HR. Then female. 4 students specialization, finance specialization, 4 students marketing, 7 students HR. So in total, 12, 11, 7. This 12, 11, 7. So this is the mean marks obtained by these students. Now we come to the next one. It is just like same as before. The same result. Now this one. Between subject efforts. But estimated marginal means are there. So overall 16.2320. Lower bound, upper bound 14.370, 18.260. Here, what is the covariate? Model exam score. Okay. Now come to the gender of students. Male, mean 15.728. Female, 16.714. Look at here. Male students, 15.8 in total. Here also, it is almost similar, 15.728. Female, 16.714. Here it is 17.07. Somehow it is different. That is why here it is given as estimated marginal means. Overall estimated marginal mean is 16.320. Gender wise, male 15.728 and female 16.714. Now we come to the specialization wise estimated marginal means. Finance 15.528. Marketing 16.069. HR 18.404. That means from this we can understand female students have performed better than male students because the mean score of female students is 16.4 and mean score of female students is 17.28. But from this, we can understand among the male students, finance students have performed better than the marketing students. Similarly, here, in the case of the female students, here, specialization. HR students have performed better Marketing students have got the next position, and the lowest performance was found to be given by the finance specialization students. So first one, we compared the gender-wise marks. Then we compared the specialization. Now interaction. Male. Finance, 17.02. Marketing, 14.435. There is no male students in the HR specialization. Already we have seen here. No. Here. Total 15 male students, 8 finance, 7 marketing. No HR students are there. So here that comparison is not found. Just dot is given. So among the male students, finance students have performed better than the marketing students. Whereas in the case of female students, look at the mean of average finance students, mean of marketing students, and mean of HR students. HR students are the best performing male students, followed by marketing female students. But the least performing students are finance students. I mean, the female finance students. Okay. So this is another comparison. So there can be different comparisons to be made at the advanced level. At the basic level, we had only 2 tables. That is description as well as the p-values. That's all. Look at here, type 3 sum of squares. That is usually selected in default. That's all. Understand? Okay. Now, so this is about ANCOVA. So once again, I repeat, in the case of ANCOVA, there are 2 scale data variables. One is dependent variable, another is covariate variable. There are 2 ordinal nominal data variables. Both are called independent variables. We have tested the influence of these independent variables and covariate variable on the dependent variable, for which we have applied the ANCOVA. For ANCOVA, we go to analyze general linear model and select univariate. As usual, dependent variable is selected. Only one dependent variable should be there. There may be any number of independent variables and any number of covariate variables. But in this case, we have only one covariate variable, but 2 independent variables. At the advanced level, we have just clicked OK and got this result. These 2 tables only were there. First one, description, that is between subject factors. And this one is between subject effects. So subject effects, what is the difference between subject effects? For that, we have applied ANCOVA at the basic level. At the advanced level, we have specified the model. It is selected in default full factorial model. Type 3 sum of squares. Intercept is included in the model. Look at this. Intercept is included in the model. Suppose if we delete this, you can find it. The result does not contain the intercept. Okay. The result does not contain the intercept. Here we had intercept, but now we have no intercept. So we include the intercept. Analyze, general linear model, univariate, go to options, add intercept, go to model, add intercept in the model, then continue, then come to the options. Here we have selected all the factors. Not only the factors, factor interactions also we have selected. Sometimes if we don't want factor interaction, we can keep it. Only factors are taken. Suppose if we want to compare mean effects, we can go for compare mean effects. For that, we have different models. LSD, then Bonferroni and CDOC. But that is further advanced. We are not going for that. So that's all. Then descriptive statistics. Okay, continue. Click OK. Now look at here. Interaction is not made here. Earlier, for finding the estimated marginal means, we had that interaction. Yes, here. You see, here we had gender and specialization interaction. But in this output, look at here, only gender and specialization are given. Gender and gender given, specialization given, but there is here, sorry. Here, gender is given, specialization is given, but interaction is not. So it is always better to include interaction also. General linear model, univariate, options, this gender also. Descriptive, if we don't want descriptive, we can leave it. Continue. Okay. Look at here. The first table is not shown. That is, this table is not shown. This descriptive statistics is not shown here. If we want that, we can include. Otherwise, we can exclude. Okay. So, if we want to include means analyze, general linear model, univariate, options, select descriptive statistics. Continue. Okay, that's all. This is all about ANCOVA. So ANCOVA, one dependent variable, at least one covariate variable, at least one independent variable. We assume that the covariate variable influences the dependent variable. There may be a correlation between covariate variable and dependent variable. That's all. Now we'll go to the Markova. As I told you, no, M stands for multivariate. Multivariate means two dependent variables, two or more dependent. Look at here. Gender independent, specialization independent, model exam covariate, university exam dependent. One more dependent is given, CIA marks, continuous internal assessment marks. So that is considered as internal assessment marks, that is dependent variable. That's all. I think the data, wait a minute, check the data. Yeah. This data is wrongly entered. Actually, this one is university marks. And this one is CAA. I had a little doubt earlier itself because the score was just 15, 16 like that. But here, you know, the scores are 60, 40 like that. So while entering the data, it is wrongly entered. You please change this in your data set also. First one is university marks and second one is CAA marks. Okay, right. Now it is very clear. Once again, we can test. Let me delete all the output. Go to analyze, go to general linear model, then univariate as usual. The same thing. Look at here, the average marks. Right. Analyze, general linear model, univariate. We should take the university exam marks. Now we can check. Look at here. The mean scores, 59.8 for male finance, male marketing, 70.14. The same results, just one mistake was there in the data entry, that's all. Okay. So you please change it. Right. Now we'll go for Markova. Markova. So two marks are there. University exam marks and CAE are there. they are the dependent variables. Model exam marks is the covariate variable. Gender and specialization are independent variables. The same thing we are required. Okay. Now go to analyze. Again, go to general linear model. But this time we have to select multivariate analysis. Okay. Here, what are the two dependent variables? University exam marks and CAA score. Then what are the independent variables? Gender and specialization. What is the covariate variable? Model exam score. First, basically, as it is, we are doing. Yeah. Since it is multivariate analysis, we have these multivariate tests. Wheeler's trace, Wilks lambda, Hotlink's trace, price, largest root. Yesterday, we discussed the same thing. So, come to the result. Only the result is displayed. Corrected model, intercept for university exam score. P-value is intercept p-value, model exam, 0.000 for university exam. So the model exam score has influenced the university exam score significantly. Okay. What about the previous one? Yeah. In this case also, look at this. Previous data we have taken mistakenly. No. In that case, model exam marks did not influence. But since we have corrected the marks now, we find that model exam influences the university marks. Very good. The same result here also. Here, let me copy and paste. Now you can see. The model exam significantly influenced the university exam score because p-value is less than 0.01. But model exam did not influence significantly the university, CAA score, because p-value is greater than 0.05. Gender has not influenced both the dependent variables. Specialization has not influenced the dependent variables significantly. Whereas in the case of interaction, it has influenced the university exam marks significantly, but the CAA score is not influenced significantly by gender and students interaction. So we can write like this. The covariate variable, that is model exam marks have influenced or have made significant impact on the university exam marks, but no significant impact was made by model exam marks on CAE marks. Number one. Then number two. What is the number two interpretation here? To gender has made no significant influence on university exam marks as well as CAA marks. Then specialization has no significant influence or has no significant impact on university exam marks as well as CAA marks. Fourth one, gender specialization interaction has made significant influence on university exam marks, but insignificant influence on CAA marks. That's all. So 4 inferences can be drawn from this. From a single table, we understand 4 items. 4 interpretations have been made. Okay. Once again, this is like basic model. If we go for advanced model, again the same thing things have to be performed. General linear model, multivariate, model definition already done. Then go for options. Here, all are taken together and descriptive statistics. Then continue. Then click OK. Right. Look at here. Different interpretations are there. Different interpretations are there. See, male, finance, and university exam. Male, marketing and university exam. Female, finance, university exam. Female, marketing, university exam. Female, HR, university exam. Male total, female total. Similarly, male finance, CAA. Male marketing, CAA. Female finance, CAA. Female marketing, CAA. Female HR, CAA. Total female, CAA. total HR, total male CA. Overall finance, marketing, HR. These are basic descriptive. But we go for advanced level. Since it is multivariate analysis, we have these 4 tests: Pillar's trace, Wilks lambda, Watlin's trace, then Roy's largest two. Model exam. Look at this. In all the cases, the covariate variable has influenced the dependent variables because p-value is less than 0.05. Whereas in the case of gender, in all the cases, it is greater than 0.05. So no significant impact. Specialization, no significant impact. Different scores, different p-values, but all are greater than 0.05. Then interaction also, all are same, but greater than 0.05. So there is no significant impact. Then come to the results. It is same as already discussed. Model exam has made significant impact on university exam, but not significantly impacting the CAA score. General exam, gender of students, both are not significantly influenced. Specialization, both are not significantly influenced. Gender specialization interaction, university exam marks are significantly influenced, but there is no significant impact of gender specialization interaction on CAA score because p-value is greater than 0.05. Ultimately, the final result. Estimated marginal means. Okay. First, gender-wise. Based on gender, we are analyzing. University exam, 66.64604. CAA score, 16.320. Grand mean. This one is grand mean. Come to the gender. Male, 66.411 in university exam. Female, 66.732 in university exam. So there is a marginal difference between male students and the female students. Male 66.41, female 66.732. That's all. In the case of CAA score, male students 15.728, female students 16.714. Here also a gradual difference. But in both cases, you see female students' performance is better than the male students. It is happening always. In 10th standard public exam, 12th standard public exam, or in our college results also, we find similar results. Come to specialization. Finance students, average marks 65.68. Marketing students 66.253. Oh, look at HR students 69.135. So best performance HR students in the university exam. Next best performance by marketing students. And the least performance was found among the finance students in the university exam. When we come to the CAA score, here also the results are similar. Finance 15.528, marketing 16.069, HR 18.404. Then come to interaction. This is the last output. Gender wise, specialization wise, and the dependent variable wise. Finance male students 62.057. Marketing male students 70.76. So among the male students, they are better in marketing, or the marketing students are better than the finance students. Among the female students, 69.32 in finance, marketing 61.70, 740, HR 69.135. So best finance, second HR, least marketing. It is one comparison. Another comparison, finance male and finance female. Finance male 62.057, finance female 69.320. Marketing male 70.76, marketing female 61.740. Just look at the previous one and this one. In the case of finance, male students' performance was lesser than the female students, because male students 62.057, female students 69.320. When in the case of marketing, male students 70.76, female students 61.70. There is a greater difference between male and female students. Male students have been better than the female students in marketing. In HR, we cannot go for comparison because there is no male student, only female students are there. Their performance is 69.135. Similarly, in the case of CAA score, finance students 17.02, marketing students 14.435. So finance students have performed better than the marketing students in CAA. When we come to female students, finance 14.035, marketing 17.703, HR 18.404. So the best performing students are HR students. Next best, marketing. Least performing, finance students. Another comparison, as we did earlier, finance male and finance female. Finance male 17.02, finance female 14.03. So male students performed better. Then marketing male, marketing female. Marketing male 14.435, marketing female 17.7. So female are better. HR, no comparison can be made. That's all about the comparison. But one more comparison is that we can compare the performance of students in the two dependent variables. So male finance and female finance. Male finance and female finance in university exam, female better than the male students. But as far as the CAA score is concerned, male finance 17.02, female finance 14.03. So male are better. In the university exam, female are better. In the CAA, male are better. Marketing, male 70.76, female 61.7. So male are better. CAA, male 14.435, female 17.703. So female are better. So in marketing, male are better in university exam, female are better in CAA score. HR, no comparison can be made, but one comparison, that is the mark bases are different. So the university exam and the CAA score of female students cannot be compared. So that's all about the Mankova. So basically, in the Mankova, I told you, there are two dependent variables and one covariate variable. All these variables are given in scale data. When we come to the independent variables, there are two independent variables. They are given in nominal data. So how to apply? As usual, once again recap. Analyze, general linear model, multivariate. So we have selected the variables, then specified the model, then we have selected the options. We wanted to display the means for overall, gender, specialization, and gender students interaction. Then we wanted descriptive statistics also. So we had gathered the results in the output file. So these are the output. Already we have discussed about the output. So this is the output, and overall we can say that the model exam has influenced the university exam marks, but not the CAA marks. Gender, no significant impact on both university exam marks and CAA marks. Specialization, no significant impact on both university marks and CAA marks. Whereas gender and specialization interaction has significant impact on university exam marks, but not significant impact on CAA marks. This is basic output. But in the advanced output, we have got so many results. These are important. That was displayed further. So we have to check all these things also. Then only we can come to, or we can draw more conclusions. That is important. Because I told you, ANOVA, we are doing ANOVA differently or separately for each variable. So number of ANOVA will be there. Number of one-way ANOVA, number of two-way ANOVA, then MANOVA, Now ANCOVA and MANCOVA correlations are there. If a club or combined correlation, one-way ANOVA, two-way ANOVA, and MANOVA. Now ANCOVA, two different ANCOVA is combined into one MANCOVA. That's all. So obviously, we should have lot of results. So the first one I showed, basic result. That is not enough. In fact, for research papers to be published in peer-reviewed journals, it is enough. If you want to publish your paper in high impact factor journals, better you can go for advanced output, like I have shown now. All these output need to be included. Even for PhD thesis, if you provide all these output measures, it will be appreciated by the examiners. So that's all about the ANCOVA and MANCOVA. It is a combination of ANOVA and correlation. So with this, I would like to thank all my dear friends and Dr. Shekhar and his team for the wonderful support. Now it is left to you, dear friends. If you have any doubt, you can ask me. Thank you very much.
Good evening, sir.
Yes, sir. Good evening, sir.
Sir, I'm Kannan. I have two doubts only.
Yes, sir.
In MANCOVA, only one covariate we have to define, or more than one covariate also we can define?
We can have any number of covariate variables, sir.
Okay. And then yesterday section, from yesterday section, I have one more doubt.
Yes, sir.
You write the hypothesis.
Yes, sir.
For that, three different hypotheses.
Yes.
Alternative hypothesis, one only you defined it. Why not you
No, no,
defined
no.
for the three alternative hypotheses?
Maybe one is showed. Okay.
Okay.
If
That
three
I
null
confused.
hypotheses are there, three alternative hypotheses are there. You can find in the Word file I have given you now.
Yes, sir. Yes, sir.
You can see, sir.
Okay. Okay.
Three
Okay, sir.
alternative
Okay,
hypotheses.
sir. I
are-
looked out it. Thank you. Thank you.
Okay, sir. Thank you. Thank you very much.
Sir, good evening, sir.
Good evening, madam.
Sir. I'm Padma. I have a small doubt. You mentioned covariant variable in this ANCOVA and MANCOVA. Is
Yes,
it
madam.
similar like a mediating variable or moderating
Yes,
variable?
yes, madam. It is like mediating variable.
It is a mediating variable like this.
Yes, madam. Yes.
So if we want to test any mediating, the role of a mediating variable is there or not, then we have to conduct this ANCOVA and
If we
MANCOVA.
go for further analysis,
Yes,
like
sir.
Amos structural unification model, in that case, this variable is termed as mediating variable.
Okay.
The terminology only is different. Here in
Okay.
the case of ANCOVA and MANCOVA, the terminology is covariate variable.
Okay.
In the case of same model, it is called as mediating variable.
Then the results will be different in SEM and SPSS?
Somehow different. See,
Result.
always in the statistics, the results are appropriate only, not accurate. Between one test and another test. Even
the results of SPSS and SEM are similar in case of this covariant and mediating?
in SPSS and Amos, the results will be mostly equal.
So in case of SEM, if I don't have, I can use this test to show the impact of mediating role?
You can use this test.
Yeah. Thank you very much, sir.
Thank you, madam. Thank you.
Professor, this kind of teaching,
Professor,
any learner can easily learn. Super,
thank you,
super.
thank you very,
You are,
thank you very
you
much,
are,
Professor.
you
Thank
are,
you for your wonderful support
Professor,
every day.
I would like to become a research faculty member. What is a form where I can get it?
Research supervisor, you want to become?
No, because I'm having 45 years experience teaching.
Okay, very good, super, Professor. Okay.
No, I would like to become a member in your STAR education.
Yes.
Like not
Dr.
that is
Sagar will give you the form.
a
You can
research
join with
faculty
us.
member.
Yes, Professor. Yes. You are
I'm
most
having
welcome, Professor.
vast experience.
You
Plus,
have vast
25 years,
experience, almost
25 degree diplomas.
a golden jubilee year you are going to celebrate.
Yes.
Your expertise and knowledge are very much useful for us.
Definitely, Professor.
We will
That's
join
why
our hands.
I'm also having more than 20 degree diplomas.
Oh, super, Professor.
You please send my email ID, that form and
Yes, Professor. Yes, sure, Professor.
okay, Professor.
Sagar,
Take care of me. Thank you.
Thank you, Professor. Thank you. Sagar, are you on the line?
Hello?
Yes, sir.
Sagar,
Sir?
Dr. Manavalan sir is asking our research forum membership form.
Yes, sir.
I tried Sagar number, sir. Professor Sagar number. He unable to take it because he's busy with some other activities. So.
Sagar, you can send it to his mail.
I tried.
Okay, sir.
Okay.
My email ID is having it.
Yes, he is having
at least in the year 23 itself, I should to become a member.
Oh, sure, Professor. Sure.
Okay, thank you, Professor. Thank you.
Thank you, Professor.
Sir, you can text me in WhatsApp, sir, with your name, sir.
No issue, Professor. But that form, even my feedback form, all details are available.
Okay, sir. Actually, last 4 or 5 days, I got received 100 plus calls every day, sir. So I could not attend
no
in
issue,
time,
Professor.
sir.
You can right now you take it because director also told no. You remember my name because in chat box and reactions my.
Manavalan sir cannot be forgotten.
Yes. Take care of.
Thank you, Professor. Thank you.
Dear participants, you
Sir,
have any doubt, please ask me.
Yeah. Sir, for both of you, we are very, very happy, sir. At this age, you are doing so much to research and the contributions that you are giving. We should be, really, it is a motivational thing for all of us. We need to learn a lot of things.
Thank you.
Generation by generation, we are, by seeing our elders, we are able to, get that motivation.
And his director Kumaresan is a very laughing face. That itself motivated to the learners.
Thank you, Professor. Thank you.
That is
very kind of
face indication. That is also important.
Thank you,
True,
Professor. Thank
sir.
you. Thank you, madam. Thank you.
Like cricket, people are telling that, no? So like that.
True, sir. True.
Body language. Appropriate time.
Yes.
But your entire body comes to the face.
Yes.
Thank you, Professor.
And it seems to be like a father. Every researcher will like it.
Sure, Professor. It is our
added advantages you are having.
It is our profound duty, Professor.
I think, hope all the researchers, young researchers will accept and admit this.
True, very true, sir. We also not only just acknowledge, we also admire for you.
Yes.
Thank you,
Yes.
madam. Thank you.
Senior person only can able to accept and appreciate the senior person.
True.
I am blessed, Professor. I am blessed to have your wonderful wishes and feedback.
Sir, will you
Because of
take
me-
sessions?
Madam.
Sir, will you take session on SEM also, structural equation modeling?
Yes, madam. In the next batch, we will do it.
Okay, so I will join definitely. I want to learn that also from you.
We will inform you. We will inform you.
Thank you very much, sir.
Thank you very much, madam. Thank you.
Padma madam is interacting like anything. Okay, super. This kind of
Learning.
this kind of young researchers is very much important to future India.
Thank you, sir.
Thank you, madam. Dear other participants, you can interact with us. If you have any doubt, you can get it clarified. Otherwise, you can just give a feedback.
Sir?
Yes.
Sir, I'm Dinesh Gopi from Commerce Department, KSR College, sir.
Come on, Gopi. How are you?
Sir, actually, உங்களெல்லாம் நான் பார்த்திருக்கேன் சார். உங்க ஸ்பீச் எல்லாம் நிறைய கேட்டிருக்கேன்.
Thank you.
ரியலி சூப்பருங்க சார். ஆக்சுவலி நான் வந்து ஒரே ஒரு சின்ன இஷ்யூஸ்னா ஃபர்ஸ்ட் டே மட்டும் கொஞ்சம் மிஸ் பண்ணிட்டேங்க சார். உள்ள வந்துட்டு பட் அதை மிஸ் பண்ணது ரொம்ப வருத்தப்படுறேங்க சார்.
Thank you. அடுத்த பண்ணிக்கலாம் விடுங்க. Don't worry.
கண்டிப்பாங்க சார். உங்களை பார்த்திருக்கேன். தினமும் நான் உங்களை பார்ப்பேங்க சார். நீங்க வந்துட்டு போறது இல்லாம பெர்ஃபார்மன்ஸ். ஆனா இவ்வளவு, ஏன்னா நான் வந்து எல்லா இடத்துலயும் சில பெர்ஃபார்மன்ஸ் பார்த்திருக்கேன். இந்த அளவுக்கான எக்ஸ்பிளனேஷன் டீடைல்ஸ் எல்லாம் வந்து கிடைக்கும்னு, அது நம்ம இடத்துல இருந்து கிடைக்கும்னு நான் எதிர்பார்க்கவே இல்லைங்க சார். ரியலி சூப்பருங்க சார்.
Dinesh sir.
Sir?
Research only, research. To get, we have to going on search and
Okay, sir.
definitely exact point we will reach. So that is
Okay,
research.
Okay, sir.
Yeah, you first day you can very well to see through YouTube link.
Okay, sir. Sure.
Hello?
Definitely, I will trust me for YouTube.
Yes, madam.
Sir, myself, Dr. S. Shantakumari
Madam?
from Sarvati Tyagaraja College, sir. I think you visited our
Yes,
college
madam.
in Spss, sir. Through
Yeah, I have
Venkatesh sir only.
so many times.
Yes, sir. Our college, most of the faculties are fans of your SPSS classes, sir. And also, we also, what is that? Create one army, like in Big Boss, there is an army is there, they are following there.
Madam.
Like you in SPSS, you are a big boss for all the learners of SPSS, sir. Definitely, you are always given an enlightenment session and you are sharing most of the valuable things in a very nutshell format, and also it is easy to digest for even a small researcher. So every time when I have an opportunity means I am ready to attend your programs irrespective of the time and date, because that much amount of passion we can get from your what is that classes. Thanks a lot.
Thank you.
God, we
Thank
are always we are not in a position to wish you. Instead of that, we always asking God to have a good, healthy and long life in your coming days, sir. Thanks a lot. Thank you so much, sir.
Thank you so much, madam. Even now, Shobha madam is there in Nagaland, no? St. Joseph University.
Yes, sir. Yes, sir. Shobana.
He invited
Yes, sir.
me for a program. I have conducted 2 programs for them.
Okay, sir. In the coming days also, we are expecting your presence, sir.
Sure, ma'am. Sure.
Sir, thanks a lot, sir.
Thank you. Convey my regards to your principal, Somu sir.
Sure, sir. Thank you, sir.
Okay, madam. Thank you, madam. Thank you.
Thank you to everyone.
Learning by earning. Professor, you are earning.
I'm earning the hearts of the participants.
Good evening. I'm Kannan from Madurai, a professor.
Sir. Please, sir. Good evening, sir.
As usual, it was a very nice presentation, and you are winning the heart of everybody. I must really appreciate it. Hope this will continue for many more years to go. Okay.
Professor, where are
Professor,
you working, Professor? In which
no,
college?
I'm in Madurai Social Work Institution.
Madurai?
Social Work Institution, M.H. Ellamuthu Trust, I'm working there.
Okay, ma'am.
No,
Okay, sir.
see,
I have
you have been
visited
talking.
that Pioneer College, you know, Meenakshi Pioneer College.
I'm not aware of it.
Puvandi, in Puvandi.
Oh, that's very far away, little far away.
Okay.
Professor,
It is in Sivaganga district, I think.
Sorry?
It is in Sivaganga district. Near
Sivaganga
Madurai.
district. Yeah, I'm in
but
Madurai.
It belongs to Sivaganga district.
See, though you are talking about Mankova, Ankova, all advanced techniques,
Yes.
at the end of it, we come to a conclusion that there is a significant difference with regard to gender and university marks or CAA marks, etc.
Yes.
Again, we go to same t-test only with the help of understanding the mean differences. So though we go in advanced level, ultimately at the end of it, we go for a simple independent sample t-test or one-way ANOVA results. So I'm just wondering, of course, you have put it in a very simplistic sentence comparing male HR,
Male finance, female
finance, all these things. But ultimately, we are going to end up with a t-test and one-way ANOVA only. I think this is the logic that one should understand. Whatever the advanced technique that we do, we should understand the base of it. And I must really appreciate you are taking a lot of efforts to say the basic things so that no one will forget the advanced techniques. And repeatedly you are telling that is the secret of your success. God bless you, Professor. Thank you very much.
Thank you very much, Professor. Thank you.
Sir, may I ask you one question?
Yes, madam, please.
Sir, I'm a research scholar, but I do have one problem that my subject is geography. For that, the data is unclassified and very differences are there. So for that vivid data, if instead of 1% significance level, if I take 5%, so
you can take 5%. Normally 5% is taken.
For that is only my question. The research result will be very different, or then it will be okay, sir?
No. We are checking at the 5% level only. Based on the p-value, we decide whether it is significant at 5% or 1% like that. It need not be significant at 1% only. Okay.
Okay, sir. Because otherwise, at the 1% level, many data, it is going to be filtered, or I'm not getting the enough data. So for that, I have taken 5% level. So it was my question. Thank you, sir.
5% is good. No issues.
Thank you, sir.
Okay, thank you.
हेलो, गुड इवनिंग सर।
गुड इवनिंग मैडम, गुड इवनिंग।
सर पहले तो बहुत आपको धन्यवाद करना चाहती हूँ कि आपने बहुत अच्छा सेशन दिया। और मैं सर हिंदी में आप कंफर्टेबल हैं?
मतलब नहीं आप अंग्रेजी में बोलिए जी।
अच्छा ओके। एक्चुअली सर हम लोग कानपुर और यूपी की से हैं, कानपुर
यूपी के
जी।
मैं आता हूँ।
अच्छा, आप आते हैं सर। मैं ये इसलिए क्योंकि मैं अभी रिसेंटली मेरा रिसर्च स्कॉलर ही हूँ, अभी शुरू हुई है मेरी रिसर्च। और आगे भी सर मैं आपके सेशन
स्कॉलर्स टू मी, आई विल हेल्प देम।
आगे भी मैं सर आपके ज्वाइन करना चाहूंगी। आपका मुझे समझाने का तरीका वो बहुत अच्छा लगा, नई चीजें सीखने को मिली।
मेरा नंबर आपके साथ है ना?
जी सर, मुझे नंबर एक बार आप थोड़ा अपना दे दीजिए, तो अगर आगे, क्योंकि जब मेरा काम शुरू होगा तब मुझे ये बहुत हेल्प करेंगे।
ठीक है मैम, मेरा नंबर इस देयर नो। ये देखो हमारा नंबर 9842602131।
9 सर
98 चैट बॉक्स में देखो मैम।
ओके सर।
9842602131।
सॉरी सर, वो चैट बॉक्स में सॉरी सर, वो चैट बॉक्स में दिख नहीं रहा, एक बार रिपीट कर दीजिए। 98
देखा नहीं? ठीक है, 98426
जी Yes, sir.
02131.
Okay, sir.
ठीक है मैम.
ठीक है सर, थैंक यू. बहुत अच्छा लगा सर, आपसे बहुत नई चीजें सीखने को मिली.
थैंक यू मैम, थैंक यू. बहुत धन्यवाद.
थैंक यू सर. वेलकम.
Hello, Professor.
Professor,
Director.
tell me, Professor.
You can provide your email also, Professor.
Yes, Professor.
Same chat box we can put it.
Yeah. My email ID winnerkumaresan@gmail.com.
You can provide in the chat box.
Yes, Professor. Sorry. winnerkumaresan@gmail.com. Sorry. Sorry, this one is wrong. Please.
Why is it we are not able to see?
This one is the right one. There was a typing mistake there.
Sir, we
Winner
are not
Kumaresan
able to see the email ID, sir.
Ma'am, I'm telling Winner Kumaresan.
WINNER.
Winner Kumaresan @gmail.com.
KUMARESHAN@gmail.com.
No, ma'am. Now you can see.
Kumaresan, correct? Professor, correct? Correct, no issue. Winner
Kumaresan@gmail.com.
@gmail.com.
Yes.
Sentimentally, like MGR, you put winner. In MGR movies, he will take first shot. Now, வெற்றி அடைஞ்சிட்டேன் தான் வருவாரு.
Success.
சக்சஸ் அது இடையில கூட வரும் படத்துல. ஆனா ஃபர்ஸ்ட் ஷாட் எடுக்கும்போது அப்படிதான்.
யுரேகா சொல்லுவாங்க சில இதுல.
So very nicely composed your email.
Thank you.
Sentimentally. I think.
Thank you to everyone who is actively participating in the entire session today. We hope you all will get more knowledge about ANCOVA and MANCOVA in today's session. We have one more last session tomorrow. We expect your active presence tomorrow also. Thank you.
Tomorrow we are going to discuss about cluster analysis. Additionally, discriminant analysis also, if time permits.
Thank you.
Thank you all of you. Good night. Take care.
Thank you, sir.
Thank you, sir.
Thank you, ma'am.
Sir, what about today's